Hello everyone. Last week I gave you the homework of numericals of exercise 8b. We have solved the numericals from 1 to 20. Those are the basic numericals from the chapter which we must need to follow. Now, today we will learn to do the rest of the numericals and then we will start the 8c, that is the electrical energy and power. So let's solve few of these problems. Now, let me tell you that all these numericals are nothing different from the previous ones. They are just a little bit more advanced problems which we might face some difficulties if we are at the beginning level. That's why I kept this portion apart. Now, let's look at the question number 23. The question number 23 tells us that a circuit is given. You can see we are asked to calculate the total resistance of the circuit, the value of resistance R, and the current flowing in R. Let's solve. Now, at topmost portion, a voltmeter is given, which is showing the reading of 4 volt. From here, a voltmeter as usual connected in parallel with the battery. It shows 4 volt. That means the source is providing 4 voltage in the circuit. Nothing special about that. Don't get confused looking at this diagram. And then there are 2 resistances. They are also connected in series. One is 20 ohms and another one is R ohms. They are in parallel and they are connected with an ammeter here and joined with the battery. The ammeter reading is 0.4 ampere as per the circuit. So I can see here is that the source is giving me 4 volt of potential difference and current flow for this is 0.4 ampere. And what are my resistances are? They are 20 ohms and R ohms which are connected in parallel. So let's see what can we solve from here. See that voltage is 4 volt. That's the potential difference. Current is 0.4 ampere. We all know the Ohm's law. The Ohm's law suggests us very simple thing. V equals to IR. Hence, if I know the value of V and the value of I can easily calculate R. What should be the formula of R? R equals to V by I. So let's solve it. Now R equals to V by I. The voltage is 4, current is 0.4, hence the value is 10. So the total resistance of the circuit is 10 ohms. This is the answer of part A of the question, that what is the total resistance. Clear? The next portion is very simple. See, it is asked what is the value of the R ohms. Now I see total resistance R is 10 and I have got 2 resistance. One is 20 and another one in R and they are connected in parallel. So what should be the value of this R if total resistance is 10? Let's see. We all know now 1 by R equals to 1 by R1 plus 1 by R2. Here 1 by R is 10, R1's value is 20 and R2's value we have to find out 1 by R. Clear? So what can I write from here? I can just bring the 1 by 20 to the left side. Let's do this. 1 by R equals to now then 1 by 10 minus 1 by 20 and the LCM will give you 1 by R equals to 1 by 20. Hence, the unknown resistance R equals to 20 ohms. This is the answer of part B. And third, another important questions for all of you, that what is the current flow through the portion smaller, the R resistance. So you can see that the net current flow is 0.4 ampere. The net current flow is 0.4 ampere. But when they are connecting, they are getting divided into two parts. One portion is passing through these 20 ohms and next portion is passing through this R ohms, whose value we have just calculated to be 20, and this one is given 20. Next, it's going to the ammeter. Clear? So how to solve that? How to find out that how much current is flowing from this R portion? Means we have to find out this value of current I1. Clear? Now here is a very beautiful formula we must need to know. It's called partitions of current. Is that we all know from Ohm's law that I equals to V by R. That is the total current flow of the circuit. And if somehow the current flow is divided into two portions, we must need to check that which portion is getting how much. If we don't want to follow a lot amount of complex calculations, we can easily do it using our formula. Let's see. Now, for solving this numerical, we must need to learn how to solve the cases of current branching in parallel connections. Usually what happens in parallel connections, that if this is a battery given, the current coming out of it, when goes to in parallel combination, the current is divided into two portions. The net current I coming here gets divided into two parts. One part is I1, the next part is I2. After the parallel combination is done, again they are reconnected and comes back. But what will happen if someone asks you that what is the value of this current I1 and what is the value of this current I2? Yes, there is a method of solving them. Let's see how we will solve this current branching troubles. So, this can help us, like this is a circuit. The potential difference from the battery, the current is coming out, goes there into a parallel combination circuit. Then goes back to battery. The current is coming here and getting branched. We can name the current here. The upper branch, which is connected to the resistance R1, is I1, and the current which is connected to the second resistance R2 is I2, and this is V. So our first task is to, just like in the Numericals 23 we have done, from the R1 and R2 we calculate the value of R using the formula 1 by R1 plus 1 by R2, that is equals to 1 by R. From here we first calculate the value of R. Just like for our number 23, the value of resistance R was total resistance 10 ohms. And using this value of R, we calculate the net current flow I using the V equals to IR formula. And the total current flow we got is how much? We got, you didn't need to calculate here, but usual cases we have to, that value we have got from the ampere reading is 0.4 ampere. Clear? So this is very simple. So after we know, or if you are given, or you have to calculate the current flow, now we can easily know how much current is flowing through each branch. The formula is very simple. The I1, the current flow in the first branch, means the upper branch. The upper branch current flow is related to the lower branch resistance. That is I1 equals to I into R2 by R1 plus R2. This is the formula for the current flowing in the branch 1. And the current flowing in the branch 2, that is I2, is related with the resistance R1. That is I2 equals to I into R1 by R1 plus R2. Clear? So this is the method of solving them. This is the method of solving the branched currents. So now let's use this formula in our problem. In our problem, the parallel connections are between one is 20 ohms, another one is also 20 ohms, and the next net current coming is I equals to 0.4 ampere. This value is 20 and this one is also 20. We are asked how much current is passing through this branch. That is, this R equals to 20 we have calculated. We are asked about this. So the formula is very simple. I2 equals to I into R1 by R1 plus R2. I is net current, so 0.4 into 20 by 20 plus 20 is 40. So divided by 2, the current flow is 0.2 ampere. This is the answer of portion C. I hope this is clear. So more further problems we will find out. We have to solve this. Thank you. Number 27, let's start. A battery of EMF. Remember, it is EMF given. EMF is represented by E and that value is 15 volt. And internal resistance is 3 ohms. That is small r is 3 ohms. That is the internal resistance. And it's connected to two resistors, 3 ohms and 6 ohms, connected in parallel. So R1 is 3 ohms, R2 is 6 ohms, which are connected in parallel. Clear? They are asked current passing through the battery, the potential difference between the terminals of the battery, the current in the 3 ohms resistors, and the current in the 6 ohm resistor. So it's quite easy. Let's first draw the circuit. Now I have a battery whose EMF is 15 volt and internal resistance is 3 ohms. That is small r equals to 3 ohms. And this is connected in the circuit, which are two resistors in parallel. One is 3 ohms, another one is 6 ohms. Clear? And then they are joined further. So that's my circuit. I have asked first the current in the circuit. Clear? So let's find out what this parallel combination gives us at first. Now 1 by R equals to 1 by 3 plus 1 by 6. Sorry. That is 1 by 2. So parallel combination gives us 2 ohms. Clear? And what is the internal resistance of the battery? That is 3 ohms. Clear? So this combination gave us 2 ohms and the battery's internal resistance is 3 ohms. Now let's solve it. We all know the formula V equals to E minus IR, where R, smaller is the internal resistance. So from here, can we solve? Yes. Capital V tells us in Ohm's law, capital V is I into R and it is E minus smaller. So, IR plus I into smaller equals to E, or I into R plus smaller equals to E. This formula we have derived before, but for your easiness I am showing it. You don't need to derive it during numericals. You can just directly write in your formula that I current flow equals to E by R plus smaller. So my that is EMF is 15, capital R is 2 and small r is 3. So 15 by 2 plus 3, 5 equals to 3 ampere. That is the current flowing in the circuit. That is the current flowing in the circuit. That's the portion of answer A. Clear? Next it is asked the potential difference between the terminals. Let's solve it. That V equals to E minus IR, the previous formula. E is 15. I current I have got now. The current is 3 ampere and small r is also 3. So 15 minus 9. Hence the potential difference is 6 volt. Clear? That is the answer of the second part. Okay. Now the third part. Now the third part is quite easy. The current flowing from each of the portions. Clear? The current flowing from each of the portions. That their total current flow is how much? Total current flow we got 3 ampere. It gets divided into two portions. The first one is 3 ohms. Next one is 6 ohms. Parallel connection and further. So if you are asked what is the current flow through this, that is I1, and the current flow to this is I2, how will you solve that? Now we all know I1 equals to I into R2. This is the R2 here, the opposite resistance, and by R1 plus R2. Net current flow is 3 into 6 by 3 plus 6. That is 18 by 9 equals to 2 ampere. That is the current flowing through the 3 ohms resistor. Clear? Now if you am asked to solve for the next part, that is I2, that means this one, this current flow, how to solve it? Now for this portion I have to choose for the R1 resistance, just like I told you in the formula. So if I am asked to calculate I2, it will be I into R1 by R1 plus R2. That is 3 into 3 by 3 plus 6. That is 9 by 9. That equals to 1 ampere. This is how we will solve the further numericals of current divisions. So this gives us the answer of last portion and the previous was of the previous portion. So I hope this is clear for now. How to solve 27. Let's solve one more numericals that will help you to understand the problems better. Let's solve a typical diagram, question number 30. The question number 30 has an ammeter here connected to two resistances in parallel These resistances are then connected to a battery of source 1.8 volt, and the ammeter is further connected here, 3 branchings. Clear? And the battery is joined. So the potential differences are 1.8 volt. The resistances are 10, 40 here, and this one is 30, 20, 60. Whenever this kind of multiple resistance problem is given, your first work is to simplify the circuit. Make it simple. How? Now by calculating the net effective resistance of that pair. Clear? Just like here we can do 2 simplifications. First we will calculate the 10 and 40 combo, and then we will calculate the 30, 20 and 60 combo. Clear? So first calculate the net resistance of the first part. The first part is 1 by 10 plus 1 by 40. If you perform the LCM, you will find out this is 5 by 40, that is 1 by 8. So the first branch, the upper branch, 1 by R equals to 1 by 8. So the upper branch resistance is 8 ohms. Clear? Next we come to the lower branch. Please remember the value, it is 8 ohms. Now the lower branch is the 3 combination of 30, 20 and 60. So 1 by 30 plus 1 by 20 plus 1 by 60. Perform the LCM. 2 plus 3 plus 1, that is 6 by 60, that is equals to 1 by 10. So 1 by R equals to 1 by 10. So R equals to 10. So the upper branch gave us 8 ohms and the lower branch gave us 10 ohms. So now we can simply draw the circuit, the simplified circuit. We can simply draw the circuit as the potential difference from the battery, as usual 1.8 volt. The upper branch was calculated to be 8 ohms. Here is an ammeter to measure the current flow in the circuit. And the lower branch is equivalent to a 10 ohms resistance, which is the parallel combination value of these 3. And the battery is 1.8 volt. Now the answers are quite easy. The total resistance of the circuit and the reading of the ammeter means the current flow and the net resistance. So net resistance is very clear in front of you. The 2 values of resistance present in the circuit are 8 ohms and 10 ohms. So what should be their added value? Let's calculate. The net resistance is 8 plus 10, as they are in series. So the net resistance is 18 ohms. Clear? This is the answer of part A. So we can see here that we have got the total resistance R to be 18 ohms and potential difference is 1.8 volt. So I know V, I know R. I am asked to calculate the current. So I will go to Ohm's law. Now V equals to IR. So I equals to V by R. Voltage is 1.8. Resistance is 18. So the answer is 0.1 ampere. And that's the answer of portion B. So you can see here that it's quite easy to solve the numericals of this chapter. They are very easy once after you can understand clearly. Okay. So our homework will be very simple. Last day I have given 1 to 20. Today's homework is 21 to 34 of the exercise 8B. Finish the exercise completely if you have any portions left from 1 to 20 before, and submit before the next class. Submit to me before the next class, just like in the PDF or picture format you have used. Clear? No failure here. Thank you everyone. If you have any doubt, please ask me.